Hello, my name is Megan Franco, and I'll be talking about the emerging issue of diversion of food waste. Before we narrow the focus to food waste, however, let's understand why there is a need for diversion from landfills. The diversion of food waste is defined as the disposal process of rerouting waste from a landfill. A few examples include composting, recycling, or reuse of the materials. This map shows the open and closed landfills in the United States. There are currently 2,000 active landfills in the U.S., and they are reaching their capacity. As more products are bought and consumed, more waste is generated, which decreases the capacity of landfills. The average person in the U.S. generates around 4.5 pounds of waste per day. Per year, that's around the height of the Leaning Tower of Pisa. Besides space, another concern with landfills is the release of methane gas, which has a global warming potential 25 times that of carbon dioxide. The degradation rates of food waste result in low initial gas collection efficiencies. Therefore, there's little methane gas recovered from food waste. In the U.S., around 254 million tons of waste are generated per year. Many states in the U.S. have run out of space to put their waste, so they transport their waste to other states. The transportation of waste is a $4 billion industry. Now knowing that the United States is one of the biggest contributors to waste, let's look at the breakdown of the waste. This pie chart shows that 1/5 of the waste landfilled is food waste. It has become a subconscious habit for many people to throw away a large portion of their food. Globally, 1/3 of the food produced is never eaten and goes to waste. In the U.S., food waste contributes 34 million tons of carbon dioxide equivalent emissions and cost about $1.9 billion in disposal fees. There are a few different methods for diverting food waste from landfills, such as composting and anaerobic digesters. Composting is the process of piling biodegradable food waste and allowing for the breakdown into compost. There are over 4,000 composting facilities in the United States. Two of the states with the largest number of composting facilities are Ohio and New York. There are 5 composting facilities located here within Richland County itself. A second technique is anaerobic digestion. Anaerobic digestion involves the recovery of energy in the form of biogas. One example of an anaerobic digester in the United States is Michigan State University, which uses organics from waste to power around 8 to 10 of their buildings on campus. Now let's compare the carbon dioxide emissions from composting and anaerobic digestion. In a hypothetical situation, given 100 grams of wet food waste, the chemical formula for the waste would be C22H173O83N1. If we look at the CO2 production between anaerobic digestion and aerobic digestion, you can see that aerobic digestion, also known as composting, produces more CO2 per ton of food waste. Currently, food waste diversion occurs through composting or anaerobic digestion. While both of these techniques produce a product such as compost or methane gas, they have long-term disadvantages, such as the unknown future market for compost. So the question arises, what to do with food waste? That's where I introduce a third technique known as hydrothermal carbonization. Hydrothermal carbonization, HTC, is more ideal in situations involving wet organic waste. During the process, wet feedstocks are heated in subcritical water where the feedstocks are decomposed. Food waste is converted to a valuable energy-rich resource termed hydrochar. Unlike in anaerobic digestion or composting, the packaging around food waste is not as much of an issue in hydrothermal carbonization. This is because the plastics break down into smaller units during the process. Hydrochar reportedly has an energy content and composition similar to lignite coal. Additionally, the produced hydrochars can be easily stored and used for energy generation as needed. Because of the high moisture requirement, food waste are better suited for conversion via HTC. To recap the presentation, food waste diversion is an emerging issue. That's because 1/5 of our municipal solid waste consists of food waste, which has a high organic and high moisture content. Instead of landfilling food waste, which uses up lots of space and results in the production of methane gas, there are various techniques that allow for the retrieval of energy-efficient byproducts. One technique is aerobic digestion, which results in the production of compost. The second technique discussed was anaerobic digestion, which results in the production of biogas. And the third technique was hydrothermal carbonization, which produces hydrochar. Of the three discussed, HTC seemed the better suited for the high moisture content of waste. Additionally, packaging around the food waste is less of an issue during HTC. And that's the end of my final presentation. Thank you for listening.